Hey everyone, welcome back. Thanks for joining us. We're coming to you live from AWS reInvent 2019 here in Las Vegas. My name's Gabe, I'm your host, and I'm here with two very special guests to talk about the AWS Jpl Open-Source Rover Challenge, Mick and Chris.
Yeah, thanks, Gabe. My name is Mick Cox. I'm with the NASA Jet Propulsion Laboratory, and I'm lucky enough to run the Open Source Rover project.
And?
Thanks, Gabe. Chris Burns, Senior ML Solutions Architect here at AWS.
Great. And let's talk about the Rover Challenge. Let's start with what is the Rover, and then we'll get into what is the challenge. Mick.
Sure. So the Jpl Open-Source Rover is something we announced about a year ago and rolled out about a year ago. It's basically a build-it-yourself Mars rover. So all the same drive capability that the rover has, on a 2,000-pound rover, scaled way back down into something that's about the size of your microwave that you can build at home. So we took all of the parts, we designed the whole thing off of parts that are really easily available. So things you can buy from Amazon, DigiKey, McMaster-Carr, just common online vendors, and then assemble with really rudimentary tools in your garage to try and inspire and inform the next generation of roboticists, scientists, and explorers. Overall, bill of materials is about $2,500 on the rover right now, and we're targeting roughly like a high school robotics club, maybe college robotics team. We've seen some FIRST robotics teams, interested hobbyists all get involved in building one of these rovers, but we're hoping that the version that we have released is kind of a base model. So people would put together the rover, have kind of the basic kit that can drive around with a joystick, but what we're hoping is that by open sourcing the whole thing, we can take innovation from the community and package that back onto the rover as they contribute that back to the rover. If you want to add solar panels to it, if you want to add a robotic arm to it, if you want to add self-driving code to it. And that's what we're announcing today is the AWS Jpl Open Source Rover Challenge, where we're hoping that the community, members of the community that are smarter than I am, could build a self-driving autonomous rover capability for our open source rover.
Okay, so let's talk a little bit more about that. What are the environments that we're hoping this rover is going to drive around in, and what's involved in teaching a robot how to drive?
Sure, so our rovers themselves drive around, for the most part on the open source rover at least, on Earth. So we're not going to send this version to Mars, but it's still very, very capable on Earth. So from the JPL standpoint, we take it out to schools, museums, universities, just kind of showcase robotics and try and get people excited. What we're really hoping is this is kind of a my first rover type project for a lot of people, and we've seen success even down to a third grade level. Really, really enterprising people come together and build these rovers, so we're really excited about that. What we've done so far on the driving and autonomous driving is we haven't really touched it, frankly, on our side, and we're really excited to challenge the community to come up with something really exciting for it.
Okay, so let's talk about the mechanics and how you actually teach a rover how to drive itself. Chris, do you want to speak a bit more about the AWS tooling that we're making available for people to do this training in? And I should note, you don't need one of these rovers to participate in the challenge. We'll have at least as far as the self-driving component is concerned, we'll have an environment set up for you. You want to talk a bit more about that, Chris?
Sure. So first off, one of the goals of AWS is to put machine learning in the hands of every developer. And as an erstwhile developer, that rings true with me. So this challenge it's all virtual in nature. You don't need any physical assets. It's all in a GitHub repo. We'll give you that website in just a moment. So we wanted to demonstrate how you can use AWS services like RoboMaker, SageMaker, a host of others to solve incredibly difficult challenges, even like deep reinforcement learning, which what this challenge brings to bear, without data science expertise or machine learning expertise.
So let's unpack that a little bit for some of our viewers who might not know what reinforcement learning is and why it's such a good fit for this type of problem. Can you explain a bit about that?
I sure can, yeah. So reinforcement learning, the third leg, if you will, of machine learning, deep learning, reinforcement learning. Reinforcement learning is about learning how to take the best action in a given scenario rather than classifying or categorizing. So this is actually going to make the rover smart enough to say, I see a rock in front of me, I can't pass the rock, I need to go around that rock. It's going to learn to do that without being told to do so.
Right, in fact, that's sort of one of the components of the challenge is we're going to give the rover different virtual environments to navigate around in, and it has to optimize for total energy consumption versus the time to get there, and that's effectively what we're going to be doing is encouraging people to train models to compete to see what's going to perform the best in these simulated environments. We have some prizes I want to mention before we wrap up. What are those prizes?
First place is $15,000, second place is $5,000.
Great, and again, for people who want to learn more about this, the best place is at the website, which is again?
Spacechallenge.tech, T-E-C-H.
Great, thanks so much for staying with us, and we have lots of exciting coverage continuing in just a moment from the stage over there, so stay with us. Thank you.